Problem number 3. Which of the following lists of integers is in order from greatest to least? Again, this is going to be a problem where we're going to want to be very careful that we find what they're asking us to find. They're asking for order greatest to least. Okay, the best way to do this problem, I think, is to put these lists of integers on a number line. So our first list, -1, -2, -3. If 0 is here, -1 is to the left of 0, -2 is to the left of -1, and -3 is to the left of -2. Now greatest to least, the greater integer is farthest to the right. So for our three integers, -1 is greatest, and then -2 is the next greatest, and -3 is the smallest. So this actually is greatest to least, this list. So it looks like A is our answer. And if we were rushed and didn't think we were going to have enough time to finish the whole test, we would just move on. But if we have extra time, we should always check the other answer choices. So let's do that. The next list is -50, -5, and 500. If I put 0 here, 500 will be to the right of the 0. -5 would be, as we're going left of those two negative integers, we'd hit -5 first, and then we'd hit -50 to the left of that. Now, my number line's not to scale. I mean, I have -50 about as far from 0 as 500, but just for the sake of ordering them, it doesn't matter exactly how far from 0 they are. I mean, really, positive 500 should be way out here somewhere, but just to try to figure out greatest to least, this is all we really need. So this list, in order from greatest to least, should be 500, then -5, then -50, but that's not what they've given us. They have -50, which is the smallest number first. Okay, same thing for the next list. If 0 is here, looking at these three negative integers, the first one I would hit as I'm going left is -200, and then the next one would be -202, and then left of that would be -220. So greatest to least should have been going from right to left, -200, which is the first one they've listed, but then it should be -202 before -220. So that's why that one's wrong. Okay, we're going to illustrate and solve for number 4. Illustrate and solve the following problems using integer chips. We're using chipboards, so you can represent your positives and negatives any way you want. The easiest way is to make a circle with a minus sign and plus signs. That way you don't need a key. If you do it some other way, that's fine. You just need to make sure you put a key to the left so everyone knows which chips are representing your positive and which are representing your negative. So I've represented -4 below, and then to that we're adding -2, so I'm going to add 2 more negative chips. Count up all our negative chips, we have 6 negatives, so the answer is -6. This next chipboard we have 6 negatives, so let's put those on there. And we have 3 positives, so I'll represent those with a plus sign. Now we have positives and negatives, so we need to look at our 0 pairs. I'm going to circle every plus and minus because each one of those equals 0. 1 minus 1 is 0, or -1 plus 1 is 0. So it's as if those aren't even there, since they're all equal to 0. And what we're left with are these 3 negative chips, so the sum is -3. Number 5 asks us to draw a chipboard which, when simplified, will have a value of +3. Well, sometimes it's best to start with the answer, so let's just put 3 positive chips there, and then there's an infinite number of answers here, but we can just add 0 pairs as many as we want, because it doesn't matter how many 0 pairs we add. Since they're all equal to 0, if we simplify this board, they'll go away and we'll be left with a +3. So we're looking for an answer something like that for this type of problem. Alright, we'll pick up the review with number 6 on the next video.